what will be the speed of the roller coaster by the time it reaches the bottom? So we have the incline here. Ooh, let's make this a little bigger. We have a mass here. Force normal is always perpendicular to the surface of the incline or the surface in contact with the mass. Force of friction is always opposite the direction of motion. And we have the force of gravity mg and theta right here. So we can say, first of all, we know that the velocity initial equals 6.0 kilometers per hour, and we're going to convert into meters per second, so 1,000 meters per kilometer. And then we can say 1 hour for every 3,600 seconds. And this is giving us 1.667 meters per second. At this point, we can say that sigma f in the y direction is going to be equal to ma. So we can, rather it's ma, y, and this is going to be equal to 0 because, again, there's no force, there's no motion in the y direction. So we can say that force normal equals the y component of gravity, so mg cosine of theta. And then we're going to say that sigma f in the x direction equals ma in the x direction. And this is going to give us mg, the x component of gravity, so mg sine of theta, and then minus force of friction, knowing that the force of friction equals mu k f sub n, so normal force times the kinetic coefficient of friction. So we can say that max equals mg sine of theta minus mu k mg cosine of theta. The mass cancels out, and we're getting that the acceleration equals g sine of theta minus mu k cosine of theta. At this point, we can solve, we should not solve, we should actually try to find the final velocity. So the final velocity squared is going to be equal to the final velocity and the initial velocity squared plus 2a delta x. The initial velocity we know is 1.667 meters per second. So we can simply say that the final velocity is equaling the initial velocity squared plus 2a delta x to the 1/2 power. And we can plug in. So v final equals, and then this will be 1.667 squared plus 2 times a. So a is now this right here. We plug this equation into this equation. And say 2 times 9.8, and then times, we'll do delta x first. So delta x is 45 meters. And then we'll do sine 45 degrees minus mu k. Here, mu k is 0.12, cosine of 45 degrees. And we are getting that the final velocity is going to be 23.5 meters per second. So this will be our final answer. That is the end of the solution. Thank you for watching.